Hello, I'm Bob Ackerman, the editor-in-chief of Signal Magazine, and welcome to our Signal Media Executive Interview. Our guest today is Steve Douglas, Senior Director of Market Strategy, Spirent Communications. Steve, welcome.
Thank you, Bob, and it's great to be here today.
Let's talk about 5G. 5G is introducing major changes for all potential users in both core and edge networks. When it comes to 5G adoption by government agencies, what key use cases are coming to the fore, and what challenges need to be overcome to realize them?
So, Bob, in terms of, I would say, 5G's adoption, especially within the government and the defense sector at the moment, there's probably be about four what I would see major use cases which are gradually starting to bubble up to the surface as the early adopters that we're seeing at the moment. And two of them are very much overlap with what we're seeing in the commercial sector today, and this is around smart warehousing and logistics and the use of augmented reality and virtual reality. And then two of them are more focused really towards, I would say, the defense sector itself, which is really around enhanced connectivity for command and control, but also the use of unmanned vehicles, multi-dimensionally around ground, sea, and air. And if we look at those, I think what's quite interesting, as I said, two of them, there is certainly an overlap with the commercial sector, especially the smart warehousing and logistics, where we're starting to see 5G being used for real-time asset tracking in these complex environments where there's obviously a lot of goods in flow. Their use of automated guided vehicles, which are being used, and also early use of augmented reality as well, Bob, in terms of, for inventory tracking. And that AR, VR is starting to overlap also into maintenance activities as well. So for example, in some of the bases at the moment, they're looking at how it could be used in terms of, say, maintenance activities on vehicles, on potential infrastructure, right even through, which I find quite interesting, into training and gradually out even into Medicare, where we're starting to see those early use cases where potentially in a forward operating base, a surgeon who's back at a central location could be providing remote support through augmented reality enabled by 5G. The other two, as I said, the command and control, it's very much about visibility and survivability today. I think one of the key opportunities with 5G is that the massive throughput and the potential to instrument everything is going to give our tactical operation centers and on forward operating bases unique real-time visibility, but also a capability that in terms of they are under attack, survivability around that. And the only thing I would caveat this with, Bob, at the moment is that, well, that all sounds great. There are still quite a number of challenges that we see the industry working through at the moment to enable these types of use cases. I think the first of these is very much around looking to utilize some of the new radio frequencies. These are called millimeter wave ranges. They're at the higher end of the spectrum. These provide the really big throughputs and speeds that are going to be required. But the challenge the industry has today with them is that they don't penetrate buildings or materials very well. Their propagation characteristics means they can be influenced by the atmosphere, trees, things get in their way. And it means they're sort of constrained to sort of short distances in line of sight. And what the industry is looking at today is new antenna techniques to allow us to exploit these radio frequencies for all the different types of environments. And that's still work in progress at the moment. And it's taking a lot of field type of testing to try to prove out and optimize the radio to perform and behave. The other one, which is absolutely unique for the defense sector, is what I would call mobile 5G infrastructure. So if you think about it from the commercial sector, the infrastructure is actually fixed. Your cell towers are a fixed asset. It's you and I who are the mobile agents in that world. We're the ones moving about, and the cell tower's got to connect. We connect to the cell tower. But when you look at the defense requirements, they actually need the infrastructure, the 5G tower, to be mobile itself. It's got to be able to move around. It's maybe on a vehicle. It's maybe hosted being moved from base to base. And that means there's two moving dynamics there. There's the actual 5G infrastructure and the things that are trying to connect to it. And that creates a radical change in how do you model and design systems to make sure that, you know, connectivity isn't lost or doesn't degrade. And then on top of that, you throw in the security into the mix. There's a huge opportunity with 5G to be potentially more secure than any communication technology we've had in the past. The challenge at this stage is trying to understand what are the vulnerabilities with it and what are the mitigation techniques that we need to put in place. And I think the defense sector is doing a great job at this stage, is trying to work through these potential, as I said, both where the risks lie, but where the opportunities to defend against those risks are. And those are sort of some of the, I would say, the major challenges the industry is trying to overcome at the moment to enable these early use cases.
Well, you've established that the 5G new core and the use of edge computing will play a key role in both defense and civilian networks. Let's look at something you've just touched upon, though. New technologies, some of which are still under development. What new testing strategies and methodologies are being developed for these technologies to ensure their resilience in contested and congested environments?
Yeah, it's a great question. And, you know, the 5G core is a key part of the architecture to enable many of these use cases. It's not just about the new radio itself. The new core network really does enable the flexibility and the new types of services that are going to offer the secure, in essence, like network slices, which will be used to enable many of these use cases. The big challenge is really coming with is that the core architecture is radically different than previous generations. It's looking to utilize the same sort of technologies that are cloud providers, the hyperscalers, are using today. So it's a service-based architecture built of small microservices hosted in a virtual environments. It's got a new abstraction technology built into it called a service mesh, which in essence really has to do all the plumbing and get all these small microservices to correctly communicate to each other. And then on top of that, all of this can be disaggregated and hosted out in different geographical locations. And what this is meaning is that you've got a very, very complex environment now with lots of moving parts hosted on different software stacks from different vendors. And the other key takeaway we're starting to see, Bob, as well, is that because of this, we're starting to see more and more updates and software releases coming out. You know, the core network, which you would see in our 4G LTE networks today, you maybe get a couple of upgrades a year. Now we're starting to see updates coming from the vendors every few weeks. So this is becoming a compounded problem, you know, multi-vendor, multi-stack environments, a huge velocity and volume of upgrades happening all the time. And to deal with that, a new sort of ideas of how to do testing has evolved. And it's really around this concept of continuous testing. It's no longer about going back into a lab environment, testing one part of it, ticking a box and saying pass, and then that's good to go for the next, 9 months out in the field. The reality is we've got to have a methodology which deals with the multi-vendors and the volume and velocity of releases coming in and continuously and comprehensively revalidates it, whether it's from performance, whether it's interoperability, whether it's security. And this is what Spirent has been pioneering for the industry for the last few years. We're doing this in the commercial sector, and we're now bringing it into government and military as well. And it's really this idea of bringing automation technologies and testing together to allow you to go through a continuous process where you rapidly validate an individual part of the core network to make sure it's performing correctly, then progressively adding the other components from the other vendors to it until finally you've validated the whole end-to-end system and the services that are having to run through it, whether it's voice, whether it's data, whether it's video services. But all of this is being done automatically through an automation framework, which allows you to continuously revalidate as any changes, any vendor software releases come into the mix. And we're seeing huge success with this already in the commercial sector, where they're sort of demonstrating time to market reductions of anywhere reducing from months down to weeks and days. And I think this is going to be a huge part of any operational network going forward, this continuous testing.
Let's turn for a moment to radio access network. What role does Open RAN play in 5G to next G networks? And secondly, how can the government ensure supplier diversity and supply chain security?
Yeah, Open RAN's an interesting evolution in the radio networks at the moment, Bob. And I would say, you know, if you look at it from a commercial sector perspective, a lot of that's been driven by a cost dynamic. You know, more competitors coming in, hopefully will obviously lower cost. The reality, though, is, and especially what the government military is looking at it and other players are looking at it, is that Open RAN offers, I think, probably 4 key advantages for the sector going forward. Number one, you certainly have diversity in the supply chain, which is really going to aid security. You know, today we through consolidation of their radio vendors over the last number of years, we really only have 3 or 4 major suppliers. So if we can diversify that supply chain by having new vendors coming into the mix, it gives us more opportunity in terms of competition, but also a mechanism to allow us to, I would call it, plug and play or replace vendors on demand in an easier way than we've ever had before. I think the secondary case is really around coverage. You know, again, if you think about it, a lot of our radio networks are designed for the large sort of macro consumer networks. The reality is government, military, and a lot of the new industries need very bespoke types of deployments for the types of geographical environments they're in. And that's complex and costly for the traditional radio players, you know, to do. So if you have a new type of open radio, which is more programmable, more customizable, it can adapt to those types of environments. And I think that's going to be a huge opportunity. And that's sort of leading into the third area I would call is innovation. Because it is an open architecture with open APIs, there's a huge potential here to develop an ecosystem of third parties who will develop smart solutions to help optimize, to adapt the radio, to allow them to fit into these environments in a more cost-efficient and flexible way. And I mean, I'd only highlight maybe the last one is, and this is maybe a bit of stargazing at the moment, or future gazing, is I think it's also going to be a critical part of the 6G system when it comes about in the next 10 years, because one of the ambitions of the 6G system, Bob, is that we want to have what is called network of networks, or 3-dimensional networking, where we have subsea married with terrestrial, married with air, married with non-terrestrial satellite comms. And this means the types of flexible radio that we're going to require to cover all of those multiple dimensions you know, isn't suited for the traditional, I would say, macro radios we have today. And I think this is where, you know, the opportunity for Open RAN is really going to show itself as we get into that sort of next G systems. As for government support, I think there's a few areas, and there's a few areas they're already doing today. I think number one is simply helping stimulate the ecosystem, whether that's through research programs, working with players like DARPA or with academia and universities, through to even funding mechanisms to allow some of the newer players a way to come in and play and compete and sort of, you know, gradually sort of come up to speed. And I think it's those new players have to be looked at in terms of another government role. I would say is really helping offset costs and some of those barriers to entry. And what I mean by that, there's costs from the perspective of our traditional service providers who would like to potentially probably adopt Open RAN, but are seeing it, well, there's a lot of challenges. It's new vendors. We've got to do a lot more testing. We've got to do potentially a lot more checks and balances. So if the government could step in and help offset those costs by maybe offering test laboratories, that'll focus on accelerating the testing of security, of interoperability and performance. I think that's going to really help smaller players prove to the industry that their solutions are robust and ready for prime time. And probably the last area I would just call it would be, do it yourself, get your hands dirty as well, adopt or bring Open RAN into some of your own testbed environments or some of your own programs. and make sure you understand how it can be used, and really hold your hand up and say, yeah, we're an advocate for this. It works. It's an additional tool in our radio toolkit now that we've got. I think the one thing I would caveat though is, should government mandate it? And I think it's probably better that they rather help stimulate the market with the opportunities for testing and collaboration, rather than pure, mandating it. And I'll also provide leadership, Bob, in terms of getting our industry to get more involved in standards participation, because it's the standards are a key way to drive that innovation. And I think it would be great, to see government and the agencies get themselves, and especially the agencies, get themselves more involved in the standards, and helping contribute to that.
Let me offer up a follow-up here, especially given that people are very concerned currently about supplier diversity in 5G. Some, I believe Melissa Hathaway, former White House CIO, is among them, have suggested we should just start moving past 5G right now and pick up an accelerated effort to develop 6G and leave 5G in the dust. What do you think of that approach? Is it realistic?
That's a great question. I think I would be more on the mindset of saying, 5G is a natural evolution to 6G. So maybe focus on using 5G as the playground to evolve your strategies towards 6G. And the reason I say that is because I personally think, from some of the work we're seeing globally, there's many of what people will say is the early 6G capabilities will actually come into the 5G system probably in the next 5 years. And these are things like using intelligent reconfigurable surfaces. So rather than always having to have lots of cell sites, a radio signal can be intelligently redirected or amplified off different types of surfaces to get them to their destinations. I think we'll certainly see that, and the meta materials that will be used around that. We're already starting to see the satellite connectivity coming into the 5G system as well in the next few releases in a few years' time. So I think I would suggest absolutely it's right to focus certainly and get involved in the 6G vision setting and gradually the standard setting of it, but that's probably an 8-year process, the way the whole industry works. I think it's more opportunistic to probably get involved in the evolution of the 5G system, where you can actually be more practical in actually implementing it. Because at that point, I think that's where you will see, or you can demonstrate leadership and market leadership. And I think there's enough scope of the system to, in the time frame to do that. So I think it's a sort of a duality there. Well, yes, get involved in the 6G and be part of that and drive that, but at the same time, don't forget about 5G. As 5G is, it's here to stay for quite a long period of time. And if you get involved and your hands dirty now, you could potentially bring a lot of great capability into it and demonstrate real leadership.
What about digital twins? They're considered something 5G could enable, and they could be used to emulate how a 5G and Open RAN network could behave. Would they simplify the complexity of innovation and testing, which is something you've touched on more than once here?
Yeah, digital twins I think is a phenomenal idea. I mean, it's digital twins and digital threads. They're not totally new in the concept. I mean, the Air Force have been using this concept for a while and creating virtual replicas of jet engine systems and their subsystems, and allowing them to be stimulated and simulated so they understand how they'll perform without actually having to have their real physical system always available. I think the relevance when it comes to 5G, as you rightly suggested in your question, is twofold. You have, first of all, 5G can help enable digital twins. The high throughput and the low latency speeds, that 5G can deliver, allows sort of near real time data and stateful information from systems or physical assets to be moved over and modeled in digital twin environments. So you've got sort of a nearly a real time virtual model of those assets. But I think what's probably more exciting to me and interesting is the second sort of use case is that the 5G network itself could also be made into its own digital twin, basically allowing the network to be continuously modeled to help optimize the design, to continuously improve effectiveness, and even to war game security in a safe way to understand, where are the risks? What mitigations could I take? And I think this is becoming more and more interesting to the industry because obviously 5G still is in its infancy. Universally, it's still reasonably limited. There's only about 1/5 of service providers globally have even deployed a small part of the 5G architecture today. So it's very, very early. There's very small amounts of real world traffic or load on those networks at the moment. So having an environment that could provide a digital replica of the 5G network as a playground or as a sandbox, I think is going to be absolutely critical. And this is a reason why Spirent developed our own 5G network digital twin framework for the industry. It's really to provide that emulated replica of the physical network itself, including all of the key functions from the radio, whether it's Open RAN, whether it's the core network itself, so that we could give our customers us this virtual sandbox or playground where they could test within it in a safe and repeatable way. Now, of course, it doesn't have to be 100% digital. It can also integrate with the real physical systems at the same time. It's stimulated by traffic generation, impairments, any security attacks can all be simulated through the systems. And I think, what we're seeing today from the early users of our systems today, the types of benefits they're getting in terms of, accelerating their R&D, the repeatable nature that they can replicate issues and faults and corner cases in a safe environment, are certainly demonstrating huge benefits and results to our customers. In fact, I think it was quite interesting. We've all, we can't mention names, but we've got a number of national security organizations and government innovation centers already using this 5G network digital twin framework, and they're testing already a diverse range of use cases from, secure and emergency communications around the new concepts of network slicing in 5G. Is that slice going to be secure? Will it guarantee priority for an emergency type of service compared to something else? We're seeing other customers use it for tactical edge types of deployments where they can model distributing parts of the 5G network out to the edge, specifically when they're looking for low latency use cases. We're seeing other customers already using it for things like spectral agility, when they're using it for resilient operations to make sure that they can model complex radio environments where there may be dealing with both, I would say, normal interference that you get in a contested environment or a congested environment, and then abnormal interference where it's actually contested and somebody's deliberately doing it, through to all the different topologies of the networks that we need to look at, like mesh networks, right through to what I find is very interesting now is even modeling and testing out things like voice and video quality in noisy environments. So if you think about it, in many environments where our emergency services have to operate or our military have to operate, the noise in those environments is absolutely maybe disruptive in terms of a commander or a lead communicating clearly a command out to the relevant parties. So the noise, how do you model what that noise environment is going to be like and make sure the audio quality can be absolutely perceived by the end users to make sure that those commands are correctly interpreted. And all of these are the use cases that can be easily executed and repeatedly executed through a digital twin. And then on top of that, because it's a digital twin, well, you can start overlaying different types of impairments, different types of what if scenarios. What happens also if I come under a security attack? What happens if somebody tries to overload the network? Does my network have the relevant resiliency to still deal with that? And the beauty of it is you're not having to invest in a huge infrastructure build out of a real 5G network to do this. In essence, it's a digital replica, on top of your workbench for you to model and play with.
Well, apropos to that, and also connected by a single thread running through this entire conversation, is the fact that the 5G network is still emerging from the lab. How can we ensure the operational live network continuously delivers on performance, quality, and security?
Yeah, I think that becomes in essence, the holy grail of it all, is that the reality is, we, as an industry, we've got to focus on 5G being as a living live system. That's where it's evolving towards. It's the same way, as I said, cloud providers operate today. And that means how we monitor the operational network for performance, for security, for quality has to radically change. The old ways are no longer as useful as they should be, because simply the new 5G network, it is cloud native in architecture. It's elastic. Functions are being spun up and moved on demand all over the architecture. And what that means is simply passively monitoring it is very, very complex to get a true end-to-end understanding when so many moving parts are in flux. And one of the approaches, the new approaches that's being adopted today by many of the largest service providers in the industry is a more proactive approach, where you use active testing embedded within the network. And what I mean by that is, this is where you have, in essence, little robots out there pretending to be you or me, continuously injecting artificial traffic into the network, making a voice call, doing a video session, doing a data stream, creating, in essence, a feedback loop mechanism to test out the pathways through the network where those flows went. Did I receive the relevant quality of service, quality of experience? Did the network perform correctly? And in essence, these active tests are providing a data set of true understanding of how that network is performing at any given point in time. And it's more proactive than simply passively monitoring, because you can create any of these scenarios on demand at any given time to give that sort of unique visibility of where any issue is at any given time. And what we're seeing today already from a number of our customers, Bob, who are using this, is that not only does it give them the end-to-end visibility they now need, it's massively important for them to do what they call rapid fault isolation. They can quickly spin up and inject traffic into the network on any pathway across any domain that makes the network, and rapidly identify where the fault or the issue is. Historically, the only way to do that was you gathered a lot of passive data, put it into a big data warehouse, and you crunched analytics against it. And maybe if hours later you came out with an hypothesis that this might be the issue. Well, rather than doing that, if I could just automatically trigger a test case to say, quickly run this, is the performance behaving good or bad? I know immediately, and I know immediately which part of the network that issue's in. And that's the type of benefits, we're starting to see. And I think where it starts to overlap, and this is probably the most exciting part of it, Bob, is really connecting the lab environment suddenly to the live environment, and enabling something we call in the industry DevOps. Historically, I created and tested something in the lab, and then I passed it over to another part of my organization, and they staged it, and then another part of my organization brought it into the operational network, and then they monitor it. And they were very siloed processes, and they were time consuming, and you needed lots of duplication of resources. Imagine a world now that the same tool sets and capabilities are used from the development chain right through to the operations, and that the testing, I test the system in the lab, but the software gets moved into the operational. The same test tools are then monitoring it in the live operation. So any configuration changes, any software updates run through this pipeline process continuously, enabling the software and the systems to be really rapidly brought through the lab testing, through the staging, right into the operational side, and really combining that together. And that's, I think, what we're starting to see today. And I think this is where this new breed of automated and active service assurance is gradually coming to the fore. And I would expect to see a lot more of this in our networks of the future.
Okay, then. Well, Steve, you've given us the 5G signal loud and clear. I want to thank you very much for your insight and observations. And to the audience, I want to thank you for viewing. This has been a Signal Media Executive Video. Good day.